In 1953, the newly crowned Queen Elizabeth II reviewed her armed forces with a series of grand displays of military might and pageantry. On July 15th of that year, it was the Royal Air Force's turn to impress the monarch. The event took place at RAF Odiham in Hampshire. The RAF had reached its peak peacetime strength since the war, boasting a total of 6,338 aircraft. The display was undeniably impressive, and as Her Majesty proceeded down the immaculate lines of planes, even the casual observer would have noted that the RAF had fully embraced the jet age.
I think the Air Force has always been a bit underconfident because, of course, the RAF has always been, for a long time, has been under threat of absorption by the other two services. And I think the Coronation Review, quite above anything else, spelled the end of that. Here we were on the ground, covering the ground, with hundreds and hundreds of operational airplanes and saying, this is our Spithead Review. This is our Aldershot tattoo. Come to Odiham and have a look at us. We're here and we're going to say. There was that. There was sort of confidence and self-assertive kind of a mood about it all.
Fighter Command had flown jets since 1944 with the Gloucester Meteor. By then, the RAF operated Meteor Marks 4 and 8, plus the vital two-seat trainer, the Mark 7. Additionally, they had de Havilland Vampires and North American F-86 Sabres on loan from the U.S., while awaiting the Supermarine Swift and Hawker Hunter. Bomber Command was on the verge of retiring its aging fleet of Avro Lincolns and borrowed Boeing B-29 Washingtons. It now had the excellent English Electric Canberra, and soon the V-Force, comprised of the Vickers Valiant, Avro Vulcan, and Handley Page Victor, would be ready to carry Britain's nuclear deterrent. The RAF was at its peak. It was not only the largest and most powerful air force globally, second only to the United States Air Force, but also the most innovative, driven by a dynamic aircraft industry.
Well, I think it was still in its wartime rundown state, and it was an incredibly capable industry right across the board. Aircraft, engines, airframes, military and civil. And a lot of prototypes were emerging from the various well-known companies like de Havillands and Hawkers, Gloucesters. It was a very, very interesting period to be around.
Well, I think in many ways it was quite pioneering, and but I think, as I say, there were many things against it. I think one was always lack of suitable or adequate funds, and projects tended to overrun their budgets, and again, building two of the same thing was probably wasting money up to extent.
Progress had been swift. Just 9 years earlier, in 1944, the Gloucester Meteor became the first Allied jet aircraft to enter service. Initially, one squadron, number 616, was equipped with Meteor Mark 1s to assist in combating the V-1 flying bombs that terrorized the civilian population in southeast England. The Mark I was powered by two Rolls-Royce Welland turbojet engines, developed from Sir Frank Whittle's design. With a top speed of around 415 miles per hour, its performance was only slightly better than the best piston-engine fighters of its time. However, the Air Ministry had enough confidence in the jet fighter to begin developing the Mark III even before the 20 Mark Is were completed. Initially, the Mark III had the same Welland engine, but by January 1945, 616 Squadron received the new Mark III, powered by Rolls-Royce Derwent engines. With this upgrade, the squadron moved to Belgium, joining the 2nd Tactical Air Force for ground attack missions, soon accompanied by a Meteor Squadron, number 504. Many anticipated that the Meteors might face the German Messerschmitt Me-262, but that confrontation never occurred. The Mark III remained in service until 1948, when it was replaced by the faster Mark IV, which had improved Derwent engines and a top speed of 580 miles per hour at 10,000 feet.
The first Meteors had what they call short squat nacelle, which limited the maximum speed of Mach number. And then they brought out what they call the long nose Meteor, very much extended pods with the engines in, which increased the limiting Mach number considerably.
2 years later, the Mark IV was replaced by the Mark VIII, the RAF's primary day interceptor from 1950 to 1955. The F-8 equipped 19 Fighter Command Squadrons and 10 Royal Auxiliary Air Force Squadrons. The de Havilland DH-100 Vampire, the RAF's second jet fighter, was also Britain's first single-engine jet aircraft, taking just 16 months from detailed design to its first flight in September 1943. It was powered by de Havilland's own turbojet, the Goblin, which had originated as an alternative to Whittle's engine when production issues arose in 1941 to 42, before Rolls-Royce stepped in. Though small in size and with modest performance, the Vampire became a popular aircraft.
I was still in the Air Force in 1944 when I was asked to go and fly the earliest Vampire that was then at Farnborough. And that was the first jet that I flew. And there's no shadow of doubt that it was a marvelous way to be driven through the sky by a jet, extremely smooth and rather fast.
As a first aircraft, I was very impressed. First of all, being a jet, it was very smooth. There was no vibration, having been flying Griffins for quite a long time, which was a pretty robust vibrating bit of machinery. To have this dead smooth power there with tremendous acceleration on the takeoff, and sitting up in the cockpit, where instead of having a couple of tons of machinery in front of you and so you couldn't see much, you had a marvelous view of the runway. And flying the aircraft was dead smooth, and it was a real pleasure.
The Vampire was by far the pleasantest and most nicely balanced of the two to fly. It was a kind of jet-propelled Tiger Moth. Small, light, responsive, terribly intimate. I mean, your shoulders were almost wider than the fuselage, and a lovely aeroplane. If you had to have a little jet aeroplane of your own to run, I would choose either the Vampire or the Seahawk, I think. It was really lovely. The Meteor, on the other hand, was big, heavy by comparison. 2 motors with all that entailed. Not as responsive by any means as the Vampire, but of course a much more capable airplane in terms of performance. The Vampire had 3,000 pounds of thrust. The Meteor had 2 times 3,500 pounds of thrust. So there was a lot more performance there.
However, it did not enter RAF service until 1946. Number 247 Squadron was the first to receive them, with 54 and 72 squadrons joining 247 at RAF Odiham to form the first Vampire wing in September 1946.
I actually converted from the latest, or the last of the Spitfires, straight onto Vampires jets. That was in Hong Kong, and that was in 1950. I had grown to love the Spitfire we were flying then, which once again was a fighter reconnaissance aeroplane,
It was the Mark 18 with the Griffin engine, with a superb performance and so on. But time goes by, and of course everything changes. And the powers that be said the Spitfire has run its course, and you're getting vampires. Well, this was wildly exciting at the time because this was the way things were. This was the pointed end. When it came to actually transferring and converting onto the aircraft, I found it to be an extremely simple task to do this. My surprise was that in getting into a Vampire, you had suddenly got an airplane where you sat in the nose. The world was lying at your feet. You didn't have to dodge past 11 feet of Rolls-Royce engine. But it was quiet in the air, and it was remarkably easy to fly. And it didn't have anything like the bits and pieces we used to enjoy in the Spitfire, like mixture controls and pitch controls and things that you could play around with and alter the sound of the engine and so on. It was like a tiger moth. It had an engine, it had a throttle. You started the engine, you took off at full throttle, you climbed at full throttle, and you chose your own power setting when you were up there. So it just seemed absurdly simple at the time. So a lot of the interest went out of it in a way, going on to jets.
The development of the type continued with the Mark III, which replaced earlier versions in 1948. The Mark III also became the basis for export versions, which were sold and licensed for production in Norway, Canada, and Australia. The Vampire's potential was further highlighted in 1948 when 6 aircraft from 54 Squadron completed the first transatlantic jet flight under their own power. Other records set by the Vampire helped maintain its public visibility.
The record-breaking Vampire came in for a great deal of interest from Italians at Ciampino Airfield, Rome. Flown by Mr. John Derry, de Havilland test pilot, the machine had travelled non-stop at a high altitude from Hatfield, covering the 916 miles in 2 hours, 50 minutes, 40 seconds, an average of 323 miles an hour. A demonstration of its wonderful flying qualities was given over the Rome airport. It's reported that there is a possibility of Vampire jet planes being produced under license by Italian firms. Royal Air Force Vampires were very much on the spot. Here, south of Blomberg, they catch a trainload of...
It also proved potent in the ground attack role. A new version, the FB Mark IV, was developed with slightly shorter, strengthened wings for carrying underwing stores. This model secured many export orders globally.
Just one more demonstration of the vital importance of command in the air.
Vampire and its successor, the Venom, were seen as ground attack airplanes, as tank-busting airplanes, if you like. Whereas the Meteors were seen as air defense airplanes only. There was never a ground attack version of the Meteor except a private venture by Gloucesters. The Air Force had no interest in a ground attack Meteor, simply because the Vampire was the more agile thing. It was the kind of airplane you'd want to be here, squeezing around among tanks near the ground.
By the late 1940s, de Havilland had begun work on a new fighter bomber powered by the more powerful Ghost engine. The DH-112 was initially designated the Vampire FB Mark VIII, but the design changes were so significant that it was redesignated as the Venom. One of the most noticeable features distinguishing the Venom from the Vampire was the shape of its wing, which had a straight trailing edge rather than the Vampire's tapered wings. The wing was also thinner and fitted with jettisonable wingtip fuel tanks. Its armament was identical to the Vampire's, 4 20mm Hispano cannons mounted in the belly. Additionally, it could carry up to 2,000 pounds of bombs. The new Ghost turbojet generated 4,850 pounds of thrust, propelling the Venom to 640 miles per hour, an impressive improvement over the Vampire's 540 miles per hour. The type first flew at Hatfield in September 1949 and became operational with the RAF in August 1952. "19 RAF squadrons in Germany, as well as in the Near and Far East, were equipped with the Venom, which also garnered many export orders from air forces worldwide. The Venom was later modified to accommodate extra radar and a radar navigator in an enlarged cockpit. This variant entered service in 1953 as an interim night fighter. By the late 1940s, RAF Fighter Command's frontline squadrons were almost entirely jet-powered. Those squadrons still operating the last piston-engine aircraft were transitioning as soon as the new jets became available.
As soon as I got back from India, having been flying DC-3s, I was about a week late for the start of the test pilots school. And the second day I was there, I think, they said, well, you missed a week's lectures on how these jets and things work, but you've got to fly one, so in you go and off you go. And I must say, it was the most intriguing experience because although the aeroplane itself is extremely simple to fly, the jet handling, of course, was extraordinary to anybody who had never done it before. And the only instruction we really received on it was a hand on the shoulder and said, for goodness sake, watch your jet pipe temperatures, which must not go over whatever they were. And off we went. But it was a strange experience, I must admit.
Training new jet pilots presented challenges, as there were initially no dual-seat jets for instruction.
There was no dual version of the Vampire, and Vampire pilots were trained by bringing them up in Meteors and sending them solo, in fact, once in a Meteor. And then you sat him in a Vampire and tipped it up onto its main wheels with its nose wheel off the ground and said, about there for landing, and patted him encouragingly on the back, and off he went. And that worked very well.
This issue was significantly eased by the introduction of the Meteor T-7 into RAF service in 1948. Originally developed as a private venture by Gloucester, the T-7 was based on the Mark IV, but with an extended fuselage to house a larger cockpit. The aircraft was a major success, with over 700 built for the RAF and Navy, securing orders from foreign air forces. In 1952, the RAF began receiving the new Vampire T Mark 11 trainer, which featured a cockpit essentially borrowed from the Mosquito and fitted onto the Vampire airframe.
Well, it was very uncomfortable. I didn't go much on it at all. We had in the past, as I said, been training these young men on the Meteor 7 to the point of them going solo and then giving them a pat on the back and sending them off in the Vampire with no dual. And so everybody was supposed to be glad that this dual version of the Vampire was coming in, but when it did come in, it was a gross disappointment. It was introduced with no ejector seats, which seemed ridiculous. Not only that, but it had a flat lid on the cockpit, which would have been very difficult to get out of wearing a parachute on the bottom and with no ejector seat. It was narrow across the shoulders, and the student and the instructor, whilst they could see clearly what one another was doing, were fairly inhibited in terms of their movement in the cockpit. And of course, although it did, I seem to remember, have an extra 500 pounds of thrust compared to the single-seat version, it was very sluggish. Not really a great success, but there we are. It was a side-by-side jet trainer that we were able to use right through for many, many years. Just that it could have been so much better than the original concept.
Well, I spent a lot of time instructing on the Vampire T-11, which quite remarkably was the tiny Vampire fighter, which had been stretched to take 2 people. I found that quite a stimulating business. I was actually a squadron commander, so I was looking after 2 courses at once. The syllabus was very extensive. And I think has since been changed considerably. But in those days, they tried to make everybody into a fighter pilot, whether they wanted to be one or not, in the first place. It wasn't, looking back on it, it wasn't really required. Why should the person whose ambition was to fly a Nimrod, why should he have to be able to do high-level aerobatics at 35,000 feet and so on? But that's the way it was, and everybody had to pass every facet of the course. And of course, you always had a percentage who simply weren't built to do that. And it was always a matter of deep regret to me when I had to scrub a chap, simply because he couldn't do a particular exercise at high level, for instance.
And here's the 535, the Swift prototype, a swept-back wing fighter developed from the Attacker. Seen here side by side at a preview before Farnborough, they make an impressive picture of streamlined speed and power.
However, it was notoriously uncomfortable. The Supermarine Swift's development began in 1946, when the Air Ministry sought a replacement for the Gloucester Meteor. The Type 535 version entered RAF service in August 1952. Powered by the Rolls-Royce Avon 114 turbojet, enabling the Swift to reach speeds of 685 miles per hour at sea level.
And now the Vickers Swift, a descendant, as it were, of the Spitfire.
Despite impressive displays at Farnborough and improvements in later versions, the Swift was unsuccessful in its role as an interceptor and was withdrawn from frontline service by 1955. The disappointment over the Swift was somewhat mitigated by the RAF's acquisition of one of the best jet fighters of the post-1945 era, the North American F-86 Sabre.
Well, the reason we're doing a Sabres across was because the Vampires, Venoms, Meteors were all out of date, ready. In Meteor night fighters, all sorts of things like that. And it moved the Air Force into the swept wing, power control, fighter jet area, transonic jets, because the Hunter wasn't quite yet ready. It's coming along, but it wasn't there. And so we got into the swept wing era about a year or two before we otherwise would have done so.
When you let go of the brakes, the aeroplane let off the brakes. That was a new experience for those of us who'd flown rounded corner airplanes with fat tires. This had, there was a lot more thrust there, and you felt it because everything was slicker. And it had fully powered controls, of course, which Vampires didn't have. They flew by cable, as the Sabre had a fully duplicated hydraulic flying control system. So as soon as he got off the ground on his first solo, and there was no dual version for Sabre, As soon as he got off the ground on his first solo, the Sabre pilot did a lot of this stuff while he learned about the pitch control. He didn't get an opportunity to learn that until he was 50 feet above the ground on his first solo. Suddenly he realized it. And the trick, of course, was to leave the stick alone.
By the time the Canadian-built Sabres entered RAF service, the aircraft was already a decade old, but it had proven itself in combat during the Korean War, and any early issues had long been resolved. The Sabre was the RAF's first supersonic jet, and its performance, combined with the experience of pilots who had flown jets in Korea, led to tactical changes.
Because it was so much slicker, we could now get, and because we could get higher, we could now come in from above these Washington squadrons, you see, and we could go down through them and up again. We could yo-yo up and down through the enemy formations, and that was an amount of maneuver, amount of inertia, an amount of stored energy that you never had on the thick-winged Vampire Meteor pair. But on the Sabre, it was very maneuverable in pitch at high altitudes, that was entirely new.
The RAF received 430 Sabres, but by 1957, they had all been replaced by the Hawker Hunter, another truly exceptional aircraft.
Ah, the Hunter, my love. The Hunter came in, and at that particular time, I had been transferred from Benson, the ferry business, to Bruggen, where the Sabres were. And the Hunter came in, and the Hunter was absolutely a dream airplane to fly. It fitted you like a glove and would do anything. You almost had to think what you want done, and the Hunter would do it for you.
The first production Hunter flew in May 1953 and entered RAF service as the F Mark I in July 1954, powered by the Rolls-Royce Avon engine. It became Britain's most successful post-war military aircraft and the first to achieve supersonic flight, albeit in a shallow dive. A Mark II version based on the Mark I but powered by the Armstrong Siddeley Sapphire engine was also produced.
The Hunter started off in Mark I and II form with the two different engines, with a lot of very basic faults. Cabin conditioning, demisting, de-icing of the cockpit, engine surging on the engine. Once we had developed it for 2 or 3 years, with the Air Force and Boscombe Down taking part, the big Avon engine was put in it, and that transformed the airplane. All the other shortcomings were put rightable. Very, very simply, it was just a matter of time and money. But in Mark IX form, I think it was probably one of the best engine-airframe combinations, which stood up to anything the pilot would give it. He could slam the engine around. He could fire his guns up to 50,000 feet. It was a very highly developed airplane. And of course, we sold it to 20 countries overseas, and it was in service with 22 air forces. And if we had more time and more airframes, we could have sold a lot more of them.
The Hunter's reputation soared when, in September 1953, Neville Duke set a new world speed record flying a Mark III with an Avon engine equipped with afterburner.
Flying a Hawker Hunter jet fighter from Tangmere has set up a new world airspeed record, subject of course to official confirmation. Checking the time at these modern high-speed bids is quite a complicated affair, as you can see, and 4 flights have to be made, 2 in each direction. Duke did this twice in 1 day, flying low above the sea off the Sussex coast. At the second attempt, he achieved an average speed of 727.6. His wife, watching from a beach, must have been thrilled to see him do the victory roll when it was all over. And certainly his daring and successful bid was a really magnificent achievement.
The Mark VI was the most produced version of the Hunter, entering squadron service in 1956 and becoming the standard day fighter by 1958. Like the Mark IV, the Mark VI could carry various stores on pylons under its wings, allowing the 4x30mm Aden cannons to be supplemented by Britain's first guided air-to-air missile, the Fairey Fireflash. A persistent issue with earlier models, where the engine ingested spent ammunition casings, was resolved by adding two bulges under the engine intakes, affectionately known as Sabrinas, throughout the service.
Sabrina was a big-breasted young lady in the entertainment world somewhere, probably Sunday night at the London Palladium on TV. And so if you just stood underneath the Hunter and looked up and half closed your eyes, you could definitely see Sabrina. And they were called Sabrinas for that reason. And everybody called them Sabrinas. I've no doubt they were called Link, capsules, Link collection, or something, but we all called them Sabrinas. Everybody knew what we were talking about.
Alongside the Mark VI, a dual-seat trainer version, the T Mark VII, was also introduced. In total, 1,972 Hunters of various types were produced up until 1966. The Hunter's enduring excellence is evidenced by its use in 22 air forces worldwide, with some aircraft remaining in service into the 1990s. Remarkably, 40 years after its first flight, 20% of all Hunters ever built were still operational. In the decade after 1945, fighters were typically designed for specific roles, such as day, night, and by the late 1940s, all-weather operations. Night fighting duties were handled by the Meteor NF-11, built by Armstrong Whitworth. The NF-11 combined the T-7 cockpit section with the Mark VIII tail, and its wing, similar to the Mark I, was modified to accommodate 420mm cannons moved from the nose. The nose of the NF-11 was extended to house the radar systems necessary for night fighting roles. This variant was further developed up to the Mark XIV, which featured upgraded radar systems and a clear view canopy. Anticipating the need for a replacement, de Havilland advanced its twin-boom design with the twin-engine DH-110. Although the RAF considered the DH-110 for all-weather operations, it was passed over in favor of the Gloucester Javelin.
It had its handling problems, but I think the Vixen had perhaps a higher performance with its particular layout, with its fairly large tail on two booms.
The Javelin, powered by two Armstrong Siddeley Sapphires, was easily recognizable by its distinctive delta wing, making it the world's first twin-engine delta-wing jet to enter operational service. Despite the prototype's first flight in November 1951, the Javelin development into an operational aircraft was plagued with issues.
Very odd airplane. I remember Bill Wharton warned me, he said, you try flying it slowly. He said the slower you get, the more you have to push the stick forward until you're getting to the point where nearly running out. He said, goodness sake, don't get to there, otherwise you'll spin in. And it's really quite frightening, sort of really slow and slow, pushing the stick further and further forward.
In 1956, the RAF began receiving its first Javelins, but despite development through 9 variants, it was not regarded as an exceptional success.
Well, it had, I think it had three
Well, main problems. One was that the wings were too fat to make it go much above 0.9 Mach number. So that we spent endless money and flights trying to stick vortex generators and things around the wings in order to get rid of the buffet at a high Mach number. Stalling characteristics were pretty bad, which was another one. And the final thing, the one that really made the whole project pretty useless, was, of course, the radar. And it was designed as an all-weather night fighter. And to be successful with that, of course, you needed the latest in radar. We never got the collision course radar installed in it. And right up to the end, we were still using virtually a wartime tail chase radar.
I flew it when I was on the examining wing of the Central Flying School, when we used to fly everything there was in the Air Force and in the Navy with our CFS examining wing ticket. The Javelin was a great cumbersome beast. We called it the Gloucester Dragmaster, and it had a couple of Armstrong Siddeley Sapphire engines in the back, and it was about all they could do to push it along.
Throughout the late 1940s and into the 1950s, the world was divided by two dominant political ideologies: pro-communism, led by China and Russia, and anti-communism, led by the United States, with Britain playing a crucial role in Europe and the Middle East. Tensions escalated sharply in June 1948 when the Russians sealed off all access to Berlin. A massive airlift of vital supplies was necessary for the beleaguered West Berliners before the blockade was lifted the following year. However, Western Europe would face the Soviet threat for decades. Initially, there were fears that while the West was recovering from the Second World War, Russia might launch a large-scale conventional attack. Given Fighter Command's responsibility for Britain's aerial defense, it had to confront fundamental issues. Were there enough aircraft to counter a large number of Russian bombers? What was the condition of Britain's air defense systems? A decision was made to enhance the air defense system, including reopening radar stations, increasing manpower, and forming additional squadrons. Massive exercises were conducted with Boeing B-29s from the United States Air Force, along with Lancasters and Lincolns from RAF Bomber Command, acting as the enemy.
The first type of attack I want to demonstrate to you is the frontal beam attack. In this case, the fighter positions himself 5 miles ahead, 3,000 yards out on a parallel course. He turns toward the B-29. Tracking is started at 1 o'clock at a range of 2,000 yards. He opens fire at 1,200 yards at 2 o'clock and continues until 4 o'clock at 700 yards. The fixed gun sight had to be used with a deflection of between 4.5 and 5 radii. We found that the Meteor 4 was unsuitable for this form of attack due to its inability to track the B-29 below 1,000 yards. The Vampire, with its better maneuverability, could track the B-29 down to 700 yards. It was also found that the fighter presented a very difficult target to the bomber. This attack, however, was found to be very difficult for the pilot to execute without considerable practice. For these reasons, this attack is not recommended.
Of course, when I was an ordinary fighter pilot on a fighter squadron, the annual exercise would come up regularly. And it was an exciting time. You often got detached. I can remember one called Exercise Beware, where we were detached to an airfield that was practically disused, and part of the exercise was to regenerate it. So yes, the annual exercises were really quite demanding, and one of the things you never forget is doing head-on attacks against Washington. So if you're an air defense fighter chap, you can well remember being up there at 36 or 40,000 feet, contrailing like mad, and looking ahead, you can see coming towards you phalanxes of B-29 superfortresses also trailing like mad. And the idea was to make a quick head-on attack for about 3 seconds and then dodge underneath this mass of bombers. This mass formation business was, as we understood it, the way the Russians planned to operate the Tu-4, which was what they called the Washington, or B-29. They planned to come along in line abreast so as to give us a major problem. And it would have been a major problem for us because there wasn't much time that you were in range before you were in collision. So that seemed to be based on good intelligence about the Russians' intentions, and that was what we were practicing against, out there in the middle of the North Sea somewhere. It bristled with guns. That was one of the difficulties about attacking it. Secondly, there wasn't much attacking time. If you were to avoid the guns, you had to do it head-on. And if you were going to do it head-on, you had a very, very short time to fire your guns before you hit the enemy anyway. And thirdly, of course, because of the way they flew, there was a great deal of mutual support in terms of their multitude of guns. And so, yes, it was a very difficult target.
Bombing up Washingtons, which are American B-29s taken over by the RAF, is just one angle on Exercise Pinnacle. And Exercise Pinnacle is the biggest test of Britain's air defences held since the war. Mock attacks have been carried out on different areas by night and day in a full-scale peacetime battle that has been fought out over many days.
And I think the period from 1945 to the end of the 40s was a period when the Air Force was putting up with the new jet aeroplanes, because they're jet aeroplanes, and everybody needed that sort of speed. And so these airplanes had actually outpaced the fastest piston engine fighters. Having said that, I think we would have been badly placed if a war had occurred at that time, because I don't think they would have been found to be very effective. From the 50s onwards, the Hunters came into service, which was a very, very fine subsonic fighter. The Americans had the Sabre, which was a very fine subsonic, and the British started to have the Canberra, which was the world's best twin-engine jet bomber. So it all changed pattern from difficulties and mediocrity in the late 40s to getting to grips with the world's best aeroplanes by the 50s.
In the ops room, the work is as realistic as if a modern Battle of Britain were being fought.
The Fox 3240, 3240, hostile 235, 3+ at 22.
And here another raiding force is attacked, Meteors intercepting Lancasters. Exercise Pinnacle is secret, but we may be sure it has proved of the greatest value.
Bomber Command was about to gain a significant advantage, as there had been advocates for a different approach to bomber strategy since before the war.
Well, Captain de Havilland realized that if an aeroplane was going to be fast and do its job successfully, it had to be streamlined, fairly lightish weight, and not carry a lot of heavy armament with it if it was going to have a high performance. So he didn't
feel at all happy with the requirements for heavy armament on the bombers with gun turrets and large crews. Well, eventually he persuaded the Air Ministry to allow him to go ahead and to build what turned out to be the Mosquito, which was perhaps the fastest and most successful wartime designed and developed aeroplane that we had in the 39-45 war.
The Mosquito had become one of the most successful aircraft ever built, so the Air Ministry was keen to develop a jet-powered version as quickly as possible. The result was the English Electric Canberra, which first flew in May 1949. Like all aircraft intended for long-term production, it was perfected on its first attempt. The first RAF Canberra was delivered to 101 Squadron in May 1951. Similar to the Mosquito, the Canberra was designed to operate fast and high enough to eliminate the need for her defensive armament, effectively fulfilling its design concept. Its speed and altitude placed it well beyond the reach of RAF Fighter Command's Meteors and Vampires, which scrambled to intercept the Canberra during exercises.
With the Canberra, in 1950, we doubled the performance of Bomber Command, which at that time had 300-mile-per-hour Lincolns. The Canberra was a 600-mile-per-hour airplane. The Lincoln was maximum operating altitude was around about 27,000 feet. The Canberra had an operating altitude of 50,000 feet and a ceiling of 55,000 feet. And so it was a quantum jump forward. And when the Royal Air Force, the rather unsuspecting Air Force, started to re-equip with Canberras in 1952, they exchanged their Lincolns, their lumbering old Lincolns, for these incredible Canberra airplanes, which had performance and maneuverability which was superior to the fighters of the time. So this was a culture shock for Bomber Command, and it was quite a problem for them. But in the fullness of time came the summer exercises, whereby traditionally Bomber Command would set up attacking forces coming in from the Low Countries to be intercepted by the fighter defences of this country. And it became very, very apparent that when the Campbells came in, the Meteors weren't going to get anywhere near them. And progressively, the Canberra force was ordered to come lower and lower and lower until the Meteors could actually catch them. And they actually had to come down to about 30,000 feet before they could do that.
The Canberra emerged as another British success story, setting numerous records for both speed and altitude. The United States Air Force was also impressed, producing and operating their own versions under license as the Martin B-57. Remarkably, aircraft designed as the Second World War was ending continued to serve in photo reconnaissance roles with the RAF into the early 21st century. The Canberra became the RAF Bomber Command's first jet bomber, and in 1955, it was joined by the Vickers Valiant. The Valiant was equipped with 4 Rolls-Royce Avon turbojets and intended for long-range bombing missions. It was also the first British jet bomber to carry a nuclear bomb, which was dropped over the test range at Maralinga, Australia, in October 1956. The Valiant was the first of 3 new large bombers designed to deliver Britain's airborne nuclear deterrent, known collectively as the V-Force. As the Coronation Review in 1953, the crowds got a tantalizing glimpse of these extraordinary aircraft, the Avro Vulcan and Handley Page Victor. These machines were the product of the ingenuity, vision, and expertise of British designers who consistently sought to push the boundaries of knowledge in all areas of aircraft design. An early example of this imaginative thinking from the British aviation industry was the de Havilland DH-108.
The DH-108 program was to find a way of getting high performance out of a modern jet aircraft and learning all we needed to learn about the swept wing advantages. And we learnt from the 108 the immensely high performance that wing could give, but it had very serious drawbacks in that the stability of the aeroplane was not adequate for development into either a commercial airliner or military aircraft, as we at that time were not able to produce artificial stability, which of course later in development of aircraft became something that was relatively normal practice.
The concept of tailless flight was also explored by Armstrong Whitworth, which built the striking AW-52 in 1948.
The thing which was most outstanding was the disharmony of the controls. Laterally, the controls were very, very heavy, and fore and aft they were exceedingly light, which made it not a very pleasant aircraft to fly in that respect. And in order to attain the degree of longitudinal control necessary, not only did it have large elevons, but it had movable sections of wing called correctors, which were hydraulically operated. It was in fact the section of wing ahead of the elevons, which was adjustable by the pilot symmetrically to give a control over the full speed range.
Throughout the 1940s, the pursuit of speed led scientists into innovative realms of research and design. Captured German data and the influx of German scientists and technicians into research establishments in Britain and the United States significantly advanced aerospace research, particularly in areas where Germany had achieved a greater level of development. Numerous projects were initiated to investigate the properties of the Delta Wing, with the ultimate goal of producing Britain's first supersonic jet fighter. The Fairey FD-2 was commissioned in 1950, but did not take to the skies until 1954.
Really had very good all-round controllability. Unlike its predecessor, the FD-1, which was a very different animal, that was oversensitive and really quite a bit of a nightmare to fly. We were expecting something a little bit like that when we first flew the FD-2, but it turned out to be a very gentlemanly, stable airplane.
Powered by a single Rolls-Royce Avon 200 turbojet, the FD-2 was destined to become the first aircraft to surpass 1,000 miles per hour. As the testing program progressed, it became clear that an attempt to capture the absolute speed record might be within reach.
But as soon as we had flown supersonically, we realized that we were flying virtually every day out beyond the existing world speed record figure. So we thought, well, if we can do this and actually do it at something in excess of 1,000 miles an hour, we'd get a lot of good publicity.
First seen by the public at Farnborough, the Fairey Delta II is undoubtedly the aircraft of the moment. And the pilot of the moment is Mr. Peter Twiss. He'd been flying the FD-2 at fantastic speeds for some time. But now he's off on the record-breaking...
The problem was the fuel consumption. As soon as you turned on the afterburner, the fuel consumption virtually doubled, and you had to plan your flight to be very adjacent to your airfield, or a friendly airfield, at all times, because you probably only had about 20 minutes, if you did a supersonic flight, only about 20 minutes reserve. In fact, in the speed record flights, which were 23 minutes, we were landing with about 15 gallons of fuel, which is certainly not an acceptable amount, not enough to go around and do a balk landing on it. Well, I realized it was quite a successful one. It was, in fact, to be the last run. We had this amazing period of fine weather in March, which is, as you know from our recent experience, fairly unusual. And the chief engineer decided that the aircraft had been flying for a week solidly, and he wanted to have a good look at it. So he said, well, this is the last flight. So we knew then this is the last chance we're going to get.
2 FD-2 aircraft were constructed, both demonstrating remarkable reliability. In 1960, one of the aircraft was sent to the Bristol Aircraft Company for modifications aimed at further exploring delta wing shapes.
Well, that was really again, an aeroplane for RAE, and they wanted to try and correlate their wind tunnel results with actual flight of a slender delta aeroplane, particularly in the transonic range, whereas they'd already had the little Handley Page airplane, which had a very unsophisticated slender delta wing, and other airplanes have been used. And because the FD-2 was available, it was converted by the Bristol Airplane Company to this slender delta form, and as I previously said, it had other things done to make it usable in that plan. And I think it proved quite fairly conclusively that the wind tunnel tests were, as found. It was very nice to fly, and it was very limited in fuel, actually, and I think one of the biggest worry was, trying to get through a program on the limited fuel on the aircraft, although we had a little more than the FD-2. But again, it was a heavier aircraft, and so things balanced out a bit. But yeah, it was very pleasant, really. I mean, there were certain differences. We put different kind of control units in, and for the FD-2 used to have a bit of lag in the system rather, and but we improved it, but we didn't eliminate it altogether.
However, as aircraft continued to break speed records, new materials were needed to construct airframes capable of withstanding the stresses and heat generated by high-speed flight. In 1953, Bristol was contracted to develop a research vehicle designed to fly at twice the speed of sound. This project resulted in the Type 188, which was constructed of stainless steel.
The objectives were to carry out research, both aerodynamic and engine development, at Mach numbers exceeding 2, which really, and to study the effects of kinetic heating, which occurs at about 2.5 onwards. At that time, the aluminium alloys were not capable of withstanding those sort of speeds, and this is why Concorde flew at 2.2 limiting. And so they had to decide what they were going to build it with, and stainless steel at that time was the only material available. And so it was built of stainless steel, which was difficult to handle and shape and mould and everything machine. So again, it didn't seem a practical proposition for future aircraft. And but the airplane itself flew beautifully. It was a very nice airplane to handle, and just as well because we had a lot of trouble with the engine surging and so on. But we still were able to, up to a point, carry out our programs.
Arguably one of the most extraordinary outcomes of the extensive research conducted during the 1940s and 1950s was the development of the Hawker Harrier. The project, which began in 1960 as the P-1127, has evolved into the Harrier GR-7, a vital component of the RAF's capabilities.
I can remember it fairly clearly because I was used as a bit of a guinea pig in that I was subjected to as little helicopter flying as I possibly could. In fact, I only did 3 35-minute trips in a helicopter at the Empire Test Pilot School. And then I got straight into the P-1127 prototype. But one had to sort of concentrate extremely hard in those days on exactly what you were doing because it was all new. I just had to take what I was told as being the thing to do, concentrate, and do what I was told. Completely new dimension. To be able to take the lift, the nozzle lever, pull it back, and gradually increase thrust until the airplane was fully supported on the engine. And of course, one of the most difficult aspects of the airplane was the flying controls, which of course had to work at all speeds from 600 knots right down to the hover, even flying backwards, sideways, and maneuvering. And that was a tremendous technical achievement by the design team at Hawkers. We had a lot of very clever people working on this project. And it was quite an eye-opener to be able to fly it. Privilege.
Reflecting on the post-war decade, it's striking how much has changed. Today, the process of developing new aircraft can span many years, often relying on advanced computer technologies. In contrast, the earlier era was marked by close collaboration between designers and pilots who would test new concepts in real time. If a design failed to perform as expected, it meant returning to the drawing board, a hands-on, iterative process. The vibrancy of Britain's aircraft industry positioned the RAF as a global leader in various aviation fields. Although the industry faced challenges related to financial resources and infrastructure, its achievements were underpinned by exceptional talent and quality.
In August 1956, the McMahon Act prohibited the sharing of US nuclear information, prompting Britain to develop its own nuclear deterrent program. The V-Force. A specification for the British strategic jet bomber was issued in 1947, calling for an aircraft capable of carrying a 10,000-pound load at 500 knots, with a range of 3,315 nautical miles and a ceiling of 50,000 feet. The bomb load, intended to be housed internally, was to be doubled over shorter ranges.
Eagle is sortie. I just point out as we climb over the hills, safety altitude will be 3,200 feet.
All 8 major British aircraft manufacturers submitted designs, including a proposal from WWII Company, based in Chatterton, near Manchester.
Okay, full FRC checks. I'll do the radio at high level. I'll leave the HF set up on Volmet so we can monitor the weather and transit, and otherwise SOP.
The design was an all-wing concept based on German research data.
Right, we'll descend from high level to be here at 6,000 feet.
After a series of major modifications and refinements, a revolutionary wing shape was chosen. This shape, almost a pure triangle like the Greek letter D, led to the universally adopted name Delta.
2, 1, now, that was 0601 Zulu.
Thus, the Vulcan became the world's first delta-winged jet bomber. The remarkable qualities of this design soon became evident. Roly Falk, the aircraft's chief test pilot, captivated the Farnborough crowd in 1955 with a climbing barrel roll. In addition to its high degree of maneuverability, the Vulcan demonstrated an exceptional rate of climb and descent. It could descend 20,000 feet in just 90 seconds and recover to level flight within 1,500 feet.
Here we go. Internal checks. Pilots, PFC order subs and fuel. All off, all lights on. Main warning lights. Up. Out. Helmets. On. Director horizons. Failure flags. Air brake switch. Crossbonds. Cool film heating.
Load check.
APP bleed switch.
Is cross-hatched.
AVS master switch.
Closed mammins.
Canopy Jersey levers. Fit in the roof monitor forward port.
Okay, the floor line. So starboard.
Canopy pointers. Safe football.
Safe lock starboard.
Reminder MI. Free right. Bomb doors emergency switch. Okay.
Let's hold the check so we'll sign for the old 700.
I need a pen as well.
Okay, let's go with the pre-start checks then.
Canopy pointers. Safe football.
Safe lock starboard.
Bombay fuel pumps.
Off.
Extra supplies button is pressed. You on outside, Chief?
Chief's on.
200, please.
Coming on.
Propane compass. It's been checked. Stand by your artificial horizon. Correct button now. Press ahead of mine. Accelerometer. Set. Clear. Start. Engine selector switch. Is to normal. Ignition switch. Is on.
RPM and R. JPT coming up. Up to 15, 16, lights on. Oil pressure 3.
In the early 1960s, early warning radar would provide the V-Force with a 4-minute warning in the event of a surprise missile attack. The Vulcans stationed at this location could be scrambled in just under 2 minutes. Vulcans were equipped with a rapid mass startup facility, allowing all 4 engines and electrical avionics to activate almost instantly at the press of a single button in the cockpit.
Zero 01, the right turn after departure, heading 340, climb flight level 180, squawk 1731. Contact departures on 255.5.
The Lincolnshire bomber bases reached their highest state of alert in October 1962. As the Cuban Missile Crisis unfolded, the Valiant, Victor and Vulcan B bombers were armed and maintained combat readiness for 3 days. Pilots and crew lived alongside their aircraft, ready to respond to the alert klaxon, which fortunately never sounded.
01, clear takeoff, service wind 30020.
Clear takeoff, 01.
It shouldn't be forgotten, that the V-Force would have carried out the first strategic retaliatory strike on the enemy defences, preceding the American SAC B-52s. The Vulcan B-2, with a wingspan of 111 feet, was 12 feet wider than the B-1 to accommodate the Blue Steel standoff nuclear weapon. It operated with Olympus 200 series engines, each providing 18,000 pounds of static thrust. A total of 88 Vulcan B-2s were built for the RAF and were initially painted with a high-gloss white anti-radiation finish. In 1969, the responsibility for Britain's nuclear deterrent was transferred to the Navy's Polaris submarine fleet. By the early 80s, the Vulcan was being phased out and replaced by the Tornado. Together with the other V-bombers, it had valiantly defended the British Isles, but had become obsolete. However, events in the South Atlantic changed that view. On May 1, 1982, at 10:50 p.m. local time, 2 Vulcans and 11 supporting Victor tankers took off from Ascension Island, marking the beginning of the first sortie of Operation Black Buck. The target, Port Stanley Airfield. 3 days later, Captain John Reeve departed from the safety of Wide Awake Airfield to commence the second mission. The flight would span 16 hours, during which the Vulcan would be refueled 5 times. This was to be the longest bombing mission ever mounted. To avoid detection by enemy radar, Captain Reeve descended to 300 feet before initiating a rapid climb to 16,000 feet. The attack had begun.
I would have felt frightened had we gone for a daylight raid. With a daylight raid, anybody who's got a gun can fire at you. With a nighttime raid, you're looking for technical electronic systems that can bring you down. We had the technology to combat those, and while the individual Argentinians, I've no doubt, were very brave and very competent pilots, I don't think they had the depth of technical expertise at sergeant chief technician level to keep their kit right at the top line to make it work. Moreover, we had the advantage on the Vulcans. We were the first raid, and the first raid has always got the advantage of surprise. No, in all honesty, I thought our technology, old though it was going to be quite good enough to get through the defences of the Argentinians by night. By day, a different matter.
Given the 1950s era bombing radar technology and the known inaccuracies of the Vulcan system, the best chance of hitting the runway was to fly across it at a 30-degree angle, releasing the 21 1,000-pound bombs at quarter-second or 50-yard intervals.
When it came to the Falklands, there was no need to bomb from 40,000 feet. It was deemed, after a lot of thought, unwise to bomb from very low level, as that would put us within the range of Argentinian anti-aircraft fire. So we elected to bomb from 20,000 feet, and as we said at the time, we've spent the first 20 years bombing at high level, the next 20 years bombing at low level, and the one operational sortie we do, we bomb at the one height that no one ever even considered in nearly 40 years of Vulcan flying would be relevant. It worked. The other considerations in picking the bombing height for the Falklands was the ballistic performance of the bombs, and there was some concern that if you dropped them from low level, there was a possibility with the low angle of graze they would ricochet off the runway rather than actually penetrate and explode. Obviously, dropping from 10, 15, 20,000 feet, not only is there more velocity on the bomb, but the point of impact is such that the bomb certainly isn't going to ricochet and will certainly penetrate and get through to the subsoil under the runway.
As they closed in on the target, the air electronics officer activated the Vulcan's powerful electronic countermeasures equipment to jam the enemy's fire control radar, which was attempting to lock on to the bomber. 2 miles short of the target, the bombs were released.
There was nothing that we could actually look at and say, that's Port Stanley and there's the airfield. But again, it didn't matter. The Vulcan has been designed to drop bombs by radar from day one. So from my point of view down the front, all I was doing was following electronic steering information, left, right, and in front of me a little needle was ticking down the range to bomb release.
20 seconds later, they hit the ground.
Our feeling was we were taking out a military target in a military operation, and I certainly had no moral qualms. I don't think anyone else in the crew. If they had, they certainly never spoke about it. We were perfectly happy with what we did. We'd have done it again.
One struck the middle of the runway. This was sufficient to render the airfield inoperable to Argentine jets that were such a threat to the task force.
The Argentinians would be aware of what was happening in the sense that, first of all, the frontline strength of the Royal Air Force is never a secret. It can't be in a society like ours. They were well aware that Vulcans would be employed if we were going to bomb the Falklands in the same way as obviously Harriers would be involved from the carrier. They were also aware of the capabilities of the Vulcan, and our initial plan was certainly for low-level grades. This was subsequently modified when we discovered the Argentinians had installed fairly sophisticated anti-aircraft weaponry. The only other aircraft physically capable of carrying the 1,000-pound bombs were the Buccaneers, and in fairness, the Buccaneers were probably a more capable aircraft with a better bombing system. The problem, as I understand, is, as on many jet engines, when you're lubricating the rear turbine, the oil is destroyed in the heat and is subsequently dumped overboard. And all jet engines lose something in the order of 3 to 4 pints an hour, depending on their size. Now, the Vulcan was designed to fly for a very long time and has got an oil tank which can tolerate that kind of loss. The Buccaneer, designed to fly comparatively short sorties, would have run out of oil for its engines after about 6 or 7 hours. One of the things that we discussed as aircrew was the possibility of operating the Vulcan over Argentina. Now, not to drop bombs, that would have been a political disaster, but just to show the Argentinians that we had the capability of getting through the defences, which I'm sure we did. And if you were an Argentinian civilian, if you suddenly hear a bomber whistling over Buenos Aires, big Delta Wing aircraft 3 o'clock in the morning making a lot of noise, we've got your attention. And one of the things that would have made the Argentinian Air Force do, as they did to a very large extent, is hold back their aircraft for home defence. Now, the Mirages, which quite well have been escorting, were in fact being held back for defence of the homeland, and the only aircraft they were being held back for was to defend against the Vulcan, which is another contribution the Vulcan made to the Falklands War. Very definitely. One of the things that did strike me, I was involved in Desert Storm. I was flying one day with the VC-10 tanker. We had 2 Buccaneers on the right wing, there to do the laser designating. We had 3 Tornadoes on the left wing, each I think with 3 1,000-pound bombs. So counting the tanker, we had 6 aircraft to drop 9 bombs, which is fine, and it worked very well. But I couldn't help but think at the time that the Vulcan could carry 14 laser-guided bombs in the bomb bay. They were slightly longer than the ballistic ones, so only 14. We could certainly have got 3 under each wing on the pylon, so one Vulcan could perhaps have done 20 bombs, probably 2 sorties a day. I think it's a shame in some ways we didn't have the Vulcan for Desert Storm. I'm sure it could have made another contribution, which would have been well worthwhile doing.
The operation to deliver 21 1,000-pound bombs to Port Stanley Airfield required considerable effort, which seemed disproportionate to the resulting bomb craters. However, the impact on Argentine Air Force strategy and combat capability was also disproportionate to the physical damage inflicted.
So after I left the Vulcans, I was on 44 Squadron when we finally folded. I did a 3-year tour in training, and then I was posted to the VC-10s, where I currently am on 101 Squadron, which is the VC-10 tanker, and by coincidence, my first Vulcan squadron when I joined the force in the very early 70s. Our role then was part of the British nuclear deterrence, and our target's obviously part of the Warsaw Pact. The way we intended to deliver the weapons was low level. By day, we would fly the aircraft by hand, looking out the window as low as we dare go, I guess 50 feet. Our training, we never went below 300 for safety reasons, but operationally, I expect most pilots have been well below 100 feet. At night or in bad weather, we had a special modification, a terrain-following radar, and you didn't need to look out, you merely followed, again, electronic steers in the cockpit, and that was selectable as low as 200 feet. The entire mission would be flown at those sort of heights, and obviously the weapon, when released, had a long time delay built in before detonation to allow the Vulcan to get clear of the effects of the blast. Unlike the Americans, who used to maintain an airborne alert with nuclear weapons, we never ever flew for training purposes with the weapons on board. They would have been loaded prior to dispersal to our bases in the event of a war. How people felt about it, it's difficult to say. It wasn't talked about, it wasn't discussed. I think it's a question of having faith in the system. We did not believe we would ever be released to drop those weapons except in extremis, presumably following a nuclear exchange which another country had initiated. I don't know anybody in 9 years that I was on the V-Force who ever had any qualms about the job, and I don't know anyone that you wouldn't have thought would have been able to do the job and be there on the day.
In August 1956, 230 Operational Conversion Unit was established at Waddington to train crews on the new aircraft. With 83, 101, 50 and 44 squadrons all based there, the giant white delta with the red cross of Lincoln emblazoned on the tail fin became a familiar sight over the Lincolnshire countryside. Continuously training on the new type, Vulcan crews consistently achieved good results in bombing and navigation exercises. Vulcans from 83 Squadron were even selected for goodwill tours, including, ironically, a trip to Buenos Aires to mark the Argentine presidential inauguration ceremonies. This classic footage from 1959 tells some of the story of the Vulcans at Waddington, while avoiding detail of their sensitive and potentially devastating nuclear armaments.
Responsible for the instrumentation and countless number of pieces of electronic equipment, this section does its job to keep the massive aircraft flying. 4 Bristol Olympus jet engines power the Vulcan. Only the best aircrews are selected for V-Force training. Captains, co-pilots, navigators, and air electronics officers must have wide experience in their respective roles. Their personal qualities count too, and until they're ready to embark upon their air training, they attend extensive specialized ground courses. A fully fledged crew is ready to take to the air. As in civilian airports, buses take them to their aircraft, which awaits them at dispersal. What fantastic machines these Delta wings are. There are 14 miles of electric cables in each one of them, 9,365 feet of tubing, and, not including the engines, over 167,000 different parts. Hundreds of thousands of nuts, bolts, washers, and rivets hold the gigantic machine together. Local control gives the okay to take off. According to the weight of the aircraft, so do takeoff speeds vary. The altitude of the airfield, temperature of the day, atmospheric pressure, all have to be taken into account. The takeoff speed is usually around 130 to 140 knots.
Roger, understand transition 3,000 feet. Flight level now 40, climbing. Delta 83, listing out.
Here they are, thousands of feet above the ground in a world of their own. How graceful they look, how different they seem, in the element to which they really belong. Sometimes on clear days we look up to the sky and see vapor trails like this. Everything they've been taught on previous dual exercises is now put into practice. High altitude bombing and navigation sorting, the practicing of emergency procedures, instrument flying and control approaches for landing. Control, dissatisfied with their line-up with the runway, told them to overshoot and try again.
Closing right to left towards runway extended centre line. Just half a mile to go. Still slightly right of centre line. Unable to get you in off this approach. Look ahead and overshoot. Delta 83, Wellington, talk down to out. Delta 83, overshooting.
The V-Force evolved into an extremely efficient organization with a strong nucleus of select staff crews holding the highest V-Force classification. In 1958, the three Vulcan B-1 squadrons gradually took on the role of spearhead for the British nuclear deterrent.
The flying side of the station's activities goes into action. No time now for unnecessary formalities. No time for anything except to get the aircraft off the ground fast.
Vulcan cockpits were equipped with shields for protection against nuclear flash, exposing only the forward vision panels during takeoff. For the remainder of the sortie, the entire cockpit was blacked out, with the route being flown solely by radar. In 1960, the RAF received the first of the larger and more powerful B-2 Vulcans, designated XH-558. It arrived at Waddington on July the 1st of that year. The B-2, with a 111-foot wingspan, 12 feet wider than the B-1, offered increased range, speed and capacity. The Vulcan B-2 was designed to carry Britain's new nuclear weapon, Blue Steel.
A glimpse of secrets, the new standoff bomb carried under a Vulcan.
After a complex fail-safe pre-launch procedure involving the first pilot, both navigators and the AEO, the missile could be fired from 100 miles away from the target. By 1963, advancements in anti-aircraft missiles rendered high-level missions no longer viable. The Vulcan, with its robust airframe, was the most suitable V-bomber for low-level operations. It was repainted in light grey and dark green camouflage and outfitted with new bulges housing terrain-following equipment.
When I joined the Vulcans, we were still maintaining QRA, which was each station at Scampton and Waddington maintaining 3 aircraft at readiness on the grounds, the famous 4-minute warning. Now, those aircraft would never fly except in the event of a war. They might taxi in spite of a pressure scramble, but never get airborne, because they, uniquely among the Vulcans, were sitting armed with operational nuclear weapons. Part of the V-Force posture was that, although we were based at Scampton and Waddington in the United Kingdom, in the event of a war, we would disperse to other military and civil bases across the country, so you don't have all your eggs in one basket. And then in the event of a 4-minute warning, there would be 4 Vulcans getting airborne from perhaps 20 or 30 different airfields around the United Kingdom to give us the chance to get airborne and disperse before any incoming nuclear weapons can take us out.
For 7 years, the V-Force maintained the Quick Reaction Alert program, ensuring the RAF operated at its highest state of combat readiness during peacetime. Blue Steel ceased operational service by the end of the 1970s. The last B-1 Vulcan flew as a testbed for Concorde and Tornado engines. Meanwhile, the B-2 Vulcans transitioned back to a conventional bomber role and were gradually phased out in the early 1980s. During and immediately after the Falklands conflict, Vulcan B-2s found a new role as tankers, temporarily replacing the Victor fleet committed to the South Atlantic. In 1984, the squadron was disbanded, and XH-558, the first B-2 to fly with the Air Force, was chosen to be the last Vulcan, preserved for display flying. Its ultimate role, delighting the crowds at air shows, became one of the most spectacular attractions. The following sequence speaks for itself.
The Vulcan is due to arrive at 2:30 this afternoon. It's arriving in formation with the red arrows. Later in the afternoon, the strongest man in the world is going to attempt to pull the Vulcan, so that between 2:30 and just before 3 o'clock you will get all the shots, the last shots that you'll ever get of an airborne Vulcan.
It doesn't, words, well, it just fails me. It's, to say it no more, it's, I'm sorry, it's just one of those things. Beautiful aeroplane. An air show, there isn't an air show without a Vulcan.
If you're interested in Vulcan survival, go and... One good thing about the arrangements for parking here is you get a good close view of... Let's get back to the red arrows, where they are. Vulcan designed to a 1946 spec. We just need to see a photograph here at a few moments. I think that the Vulcan, which was the result of thoughts on paper in 46, passes slowly over the B-17. But there, that one big shot in the way, which was just about going out of service roundabouts there. But they had just gone out of service. It's the B-2. The definitive version of the Vulcan, considerable redesign of the wing leading edge, among other things. It was the world's first four-jet Delta bomber. Great big farewell written on one of the bombers. Designed originally as a high-altitude, high-speed bomber, cruising at near Mach 1, just below the speed of sound, at some 60,000 feet. Then when its role changed, when surface-to-air missiles began to acquire the range and lethality to make that a dangerous game, Vulcan came back with a low-level range before the Vulcan, the last of the great Avro four-engine bombers and maritime reconnaissance aircraft, going back through the Shackleton and the Lincoln and the Lancaster. Vulcan was, I suppose, probably the last aircraft in the RAF which was designed for scramble operations.
The wing wave was beautiful at the end. As usual, she gave a beautiful display. When they played the last post, that was when emotions really overcame me, and I did break down at that point. Then went over to see her, stood very close by, and then when they said that they were going to allow people to get a bit closer, I actually broke ranks then and went right up to her. I shouldn't have been there, I don't suppose, but did manage to get into the cockpit and have two very special souvenirs. One is the soot out of her exhaust, and the other one, a bit of axle grease, and those will stay there forever.
Oh, just sum it up in one word. Wow.
This is the last flight. Oh, that's how it's being built.
This is the last display. Prime example of the British aircraft industry in the days when we were able to produce really great aircraft like this.
Would you like to see it continue flying?
Oh yes, I don't think they have any shortage of volunteers from the crew to fly it, or from the ground crew either.
Here we are, ladies and gentlemen. There you go, come on, come on, come on.
Spectators has turned out to see the last official propaganda display of the Vulcan bomber. It was an emotional day for the plane's crew and
displays throughout the country, earning a special place in the heart of aviation enthusiasts. Capable of reaching speeds of more than 600 miles an hour, it can fly for 4,000 miles without refueling. But now it's flying days seem over.
What were they thinking of when they say they want to scrap it? Have they ever gone to an air show and seen the effect it has on the spectators? Well, this particular aircraft was so unique. To some of them, they were just a nuisance, the noise they used to make. But that's the name of the game. As I say, I feel angry, frustrated, and wish I could do something about it. There's a lot of Roman charity, is there? To actually think that that would be the last time I saw the Vulcan flying. The plane has given me a lot of pleasure over the years, as well as millions of others, and to think that that was going to be the last time it could possibly fly was a very sad thought.
I believe that aircraft are there to fly. We've got plenty of Vulcans in museums, so I'm afraid I'm not terribly sentimental about aircraft that are kept on the ground. I don't think anybody's finding about the Vulcan. It's a unique machine.
They shouldn't get rid of it.
In the autumn of 1992, XH-558's airframe reached the end of its fatigue life. The expensive major service needed to keep this aircraft airworthy for another decade was denied funding. It appears that the aircraft, which played a crucial role in maintaining peace during the dangerous Cold War era and influenced the designers of Concorde, has been permanently grounded.
I hit the CFG just right. How was the timing? You trust guys to through. It's the first step. Everybody else come on. Yes, right. Good to see. How's your holiday? Eh? Sorry? Cool. What are your thoughts? Good health for the last time now.
Well, I think we're all very sad. End of an era, and
First, good mate.
it's
It's
a great shame, but you know, we've had a good run for our money. I think the public enjoyed the aircraft. We've enjoyed flying. It's been a great privilege to be the last aircrew of the Falcon.
Aviation, the art of aeronautics, began with the dreamers, inventors and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.